Hi everyone, I'm Ann Vu, a product manager on the Exchange team. Today, I want to introduce you to someone that has been on the Exchange team for 13 years. Clarke is a GM on the Exchange team, and today we're kicking off a series of videos that we're affectionately calling Geek Out with Perry. Did I mention Perry has a PhD in material science, solid-state physics? The goal of this series will be to go deep technically in key areas related to Exchange Server. We'll also be soliciting your feedback and requests for topics. To kick off the series, Perry is going to talk about why utilizing large capacity disks changes the way we use storage for Exchange. So Perry, what's your philosophy on managing storage efficiently?
Well, philosophy sounds awfully fancy, but before we get to that, let's talk a little bit about some of the context that's going on in the industry over the last few decades that helps to drive our thinking. In an awful lot of different dimensions, there's been some pretty dramatic changes in the hardware that we build computers with. But one of the things that have been changing the most dramatically has been the capacity of disk drives, right? If you look over the last 30 years, we've seen a 100,000 factor change in the size of disk drives. Okay. That's a huge benefit to human beings around the planet. It means it's almost 100,000 times cheaper to store data. It makes it easier to store very large amounts of data, lots of email for a long period of time. But at the same time those disk drives are getting bigger, they've been getting faster, but not all that much faster. Over the same time frame, there's only been about a 50 times improvement in the speed of those disk drives. And in sort of the last half decade or so, there's really been no improvement of the speed, whereas the size of the disk drives keeps getting bigger.
So why don't we use solid-state drives? I heard they have really good throughput.
Right. So it's true that one of the options would be to try and take advantage of other technologies as a way to deal with the I/O capacity. And essentially, you have to start thinking about building architectures that are sort of a hierarchical storage model. Okay. You put some of your data on some class of storage that is big and slow, and other data on disk drives that are fast and small. The problem with solid-state disk drives is they're so dramatically smaller. Their cost per bit is order 50 times dollar per bit of the big disk drives. Okay. So the challenge then is coming up with a system that actually ends up being cheaper if you split your data in two. One thought experiment is, let's imagine you can find 1% of your data. Let's actually make this easier. 2% of your data that's got 90% of your I/O. Okay? Mm-hmm. And over here, you're going to have you've got your cold data that's got 98% of your data, and magically only has 10% of the I/O associated with it.
So what's an example of cold data?
Cold data would be just the bodies of emails, or in particular bodies of emails that are, say, more than a week old. You want to see them occasionally, but you don't open them very often. Okay. Hot data would be indexes, okay? In fact, if you go down to 2%, it's some small fraction of the indexes in the system. To get to a system like this, you have to come up with a very dynamic model for allocating the data between these two things. In a model like this, if the cost per bit is 50 times as high, you can see you're already spending 100% of your budget on your solid-state disk drives, and you still need to buy a whole bunch of disk drives to store all that space. So
that gets pretty expensive.
So yeah, in this kind of a model, you actually end up spending close to 2x in a model when you separate the hot and cold data. This is a broader sort of design philosophy that we've come to a strong conclusion on, which is co-locating hot and cold data is one of the key things necessary for getting to a lowest cost solution. Mm-hmm. And what that means is then that you really need to take a hard look at the underlying I/O perf of your system to take advantage of these big, cheap disk drives. If you can get to the point where you are space-bound because your I/O efficiency is so good, then you can use all of your data on this big disk drive, right? And you only have to buy 2% more disk drives for that extra space. You don't have to spend any money on the solid-state disk drives. And now your costs are literally one-half what they were originally.
So when you're engineering Exchange, what do you think about for these changes?
Right.
and using capacity that way?
So, the I/O performance is a key enabler for being able to use these cheap and very big disk drives. But it's far from a sufficient story to get to what we really want, which is to enable people to have really large, low-cost mailboxes, so that you can fill up these disk drives with data that you want to reference. You don't have to worry about deleting it and that sort of thing. But to do that, you really have to take a look at a whole suite of investments. You need to look at your data protection strategy. You need to look at your risk management strategy at your company around discovery and retention policy. You need to make sure that user experience reflects the large amounts of data that end users can now work with, and we give them the right tools to do that. The client performance needs to match that growth in storage. And then when you're managing the system, one of the key things is you need to be able to move people and upgrade them at the mailbox level without taking them offline. If their mailbox is 100 times bigger, you can't take them offline for 100 times as long as you used to 10 years ago to replace a piece of hardware or upgrade to the next version. And then finally, underlying an awful lot of this stuff, both the user experience and the discovery and cross mailbox, is making sure your engines of doing searches and sorts and so on really are capable of dealing with the flood of information that's coming in, can return searches across lots of mailboxes or across all the data in one mailbox, and do it very quickly.
Okay. So data protection and data replication would be an excellent topic for our next video. That's it for our first Geek Out with Perry. We hope you find this information useful. Please feel free to leave us comments and look for another session from us in the next few weeks.